Good morning, boys and girls. Welcome to our third and final lesson of the week. Okay, you can see I brought you in a bit closer. You're really close to the board. And the reason is we really need to look at the periodic table closer by. And the reason is that in our first two lessons, we looked at the periodic table as a whole. Okay, we looked at different groups, different families of elements. We actually saw some in action. We spoke about it. But now we're going to look at each element separately. Okay, that's why I brought you closer. Now, when you look at this periodic table, you can see that each little block where an element lives, you've got a letter. So, for example, here I've got the letter B. Okay, now B is the symbol of the element whose name is boron. Okay? Most periodic table will have, not all, but some of them will have the name under the symbol itself, but not all of them do. Okay. Now, I think at this point, I should say that you need to know the symbol and the name, okay, up to calcium, which is the 20th element. Okay, up to calcium, up to here. Okay, so you need to know the first 1, 2, 3 rows, all those rows, all these 3 periods, plus in the 4th period, you just need to know potassium and calcium. Okay, it's one of these things that you got to remember, plus there's going to be a few others that I'll talk later. Okay, but you need to, if I tell you what's the symbol of carbon, you need to say, oh, it's C. Or if I tell you what's the name of the element that starts with F, the symbol is F, what name of the element is? Fluorine. Okay, I think some of you already did some of that last year, but now we really need to know that up to number 20. Okay, so yeah, boron, B is the name, B is the symbol. Carbon, the symbol is C. Nitrogen, the symbol is N. Oxygen, the symbol is O. Fluorine, the symbol is F. Now, neon, this element here, which is in the noble gas, neon, okay, this element is Ne. Capital N, little e. You'll see that some of the elements have one letter, and then it's always capital, but some of them have 2. And if they have 2, okay, there might some be even 3. But if they have 2 or 3, the first one must always be capital, and the second one needs to be non-capital. And there's a really good reason why that is. If somebody write NE like that, then they will lose a mark but in a test. But more importantly, there's a reason why that is. So I think I'll work with let's use the symbol or the symbol for silicon. Okay, silicon is Si. Silicon. Okay? So nice little element that without it we wouldn't have computers. Really important. Okay? Now if somebody was to write Si or silicon instead of big S, little I as S, big I, capital S, capital I, then that's not silicon. That's something completely different. This is silicon iodide. Okay? So next week we're going to learn about compounds, which are when 2 elements or more combine together something new, compound. Okay, so if you write capital S, capital I, it's not silicon, it's something completely different. So very important that you do first letter capital, second letter if there is, and non-capital. Okay, so that's about the symbols, and I'm reminding you, you need to know up to calcium. Okay, you need to know. There's some tricky ones. Okay, well, a lot of them make sense. So B for boron, okay, Be for beryllium, Li for lithium, but there's some tricky ones. I'll go through some of the tricky ones. So Na is sodium. A lot of people will say sodium is S, okay, but no, it's Na. Why? Because the Latin word for sodium is natran, or in Hebrew we say natan. I don't know, in Latin it's probably similar. So it doesn't always work. Let's think about, all right, that phosphorus is P, chlorine, that makes sense, S for sulfur, K. Sorry, disappeared here. K, okay? What does K stands for? Potassium. Okay? Just need to remember that. Now, apart from all the elements until calcium, I've got Fe, which is iron, Co, cobalt, Ni, nickel. I'm running out of space here. I'll just have to say Cu, which is copper, Zn, which is zinc, Ag, silver, Au for gold. also these, how many is it? 7 elements I'd like you to remember. So symbol and name, you need to be able to know from one to the other. We're going to use a lot of we'll use them, some of those for magnetism later this year. And these one you'll just need in the next few years. So it's good to remember those as well. Please remember it. I will put a link to a song on YouTube, which is kind of a fun song about the periodic table. I think you might have probably seen it already in prep, maybe. And it's a good way of remembering some of these elements. So listen to that song. I know you're going to enjoy it. Students always enjoy it, and it's good to also remember. Okay, I'm going to pause here, and I'll move you a little bit further away. Hey guys, I moved you a little bit further to a more safe distance so I can just move around a little bit more. Okay, well, you're not going to need the periodic table to see it straight away. You will still need it, but not all the time. Okay, so we are happy with the symbol that each element has, and we're going to try and we'll remember until calcium and a few of the others. Now, if you look even closer, you'll see that next to that symbol there's some numbers. Now, in each periodic table it's slightly different. Okay, but you will always see 2 numbers, one small and one bigger. Sometimes mostly the small one is on top, but sometimes and then the big one at the bottom, but sometimes the other way around. We need to just try and understand what these numbers mean, and we had a chat about that in our live lesson last week. As I promised, I'll go in more details. So let's look at carbon. C is carbon. Okay. What does 6 mean? What is this 6? That's called the atomic number. Okay? The atomic number. And what is the atomic number? The atomic number is basically what makes the element that element. What makes carbon different to nitrogen or to oxygen? Well, it turns out what makes it carbon is how many protons it has. Okay? So it's the number of protons. Okay? Now, in a neutral atom, and I'll explain what a neutral atom is in a minute. In the neutral atoms, it's also the number of electrons. Okay? So carbon has 6 protons, and it also has 6 electrons. So it's the number of protons, okay, or number of electrons in a neutral atom. Okay, guys? You obviously need to write these things. Okay, so pause me as I talk, write these notes. Okay? Right, what is a neutral atom? So, first of all, in grade 8, as far as we're concerned, all atoms are neutrals. What does it mean? Neutral means have equal number of protons and equal number of electrons. So, carbon has 6 protons in the nucleus, remember? And it also has 6 electrons orbiting around. Why do we call it then neutral? Well, as we're going to see later this year, and we already mentioned that. Electrons have a negative electric charge, whatever that means. We'll expand a little bit later this year. So it has negative electric charge. Proton has positive electric charge, okay? So if carbon has 6 protons, 6 positive charges, but also 6 electrons, 6 negative charge, overall it's neutral. It balances each other out. So in neutral atoms, which is what are we talking about this year, it's the same. It has atomic number as the number of protons or the number of electrons. Okay? Next year we're already going to look at non-neutral atoms. Okay, so this is the atomic number. The big number is called the atomic mass. Okay? And that's also important, but not as important the atomic number. Okay? Alright? So atomic mass is basically how heavy the atom is. And if you remember for our lesson on the atom, what makes the mass of the atom is the protons and the neutrons, not the electron. The electron has very, very little mass. Okay? So it's the number of protons plus the number of neutrons. We forget about the electrons here. Now, let's try and figure out, let's first of all write it down. So it's the number of protons plus number of neutrons. Okay. Now, let's try and figure out together how many neutrons does carbon have. Well, It has 6 protons. I'm going to write 6p. So protons, 6p. Now, I don't know how many neutrons does it have. I don't know. Okay? But I know the number of protons plus the number of neutrons will be equal to, correct, it will be equal to 12, because that's what atomic mass means. Atomic mass is the number of protons plus the number of neutrons. Add the number of protons to the number of neutrons, you got the atomic mass. So this is a question in algebra, isn't it? How many neutrons, okay? How many neutrons does carbon have? Well, it's 12 minus 6. It's 6 neutrons. Okay? There are 6 neutrons. Okay? N for neutrons. Okay? Does that make sense? This is the kind of maths. It's the first time we're doing a little bit of maths in chemistry. That's the sort of question I can ask you in a test. And look, that's a question I'm going to ask you to do at the end of this lesson. By looking at the atomic number, you should know how many protons, how many electrons there are. Okay, there's 6 protons, 6 electrons. Okay, it's a neutral atom. How many neutrons? It's always the atomic mass minus the atomic number. Maybe let's write that down. I'll just pause you here. Okay, we're reaching the end of the lesson. It's a bit of a long one. So I've written it. I think this is a really important one for you guys to write, because that's the trickiest bit here. Okay. If you want to know the atomic number, or if you want to know the number of protons, you just need to look at the atomic number. That tells you how many protons and also how many electrons there are. If you want to know how many neutrons there are, you need to take the atomic mass and subtract from it the atomic number. Write it down, guys. Okay? And to finish up, we just look at 3 examples, the kind of question I'm going to ask you in a test. So H, what does H stand for? What symbol is that? Correct, hydrogen. Atomic number is 1, atomic mass is 1. So let's just write down for each one of these how many protons, electrons, and neutrons there are. All right, P, E, and N. Okay, so protons, I know that there's just 1, because that's the atomic number. Also electron, there's just 1. How do I know how many neutrons there are? Well, I can just use this equation, for example. I'm going to take the atomic mass, which is 1, minus 1, that's equal to 0. So there's no neutrons in a hydrogen. Okay? All right, I'm going to just check it again. If I add the number of neutrons, which is 0, to the number of protons, 1, I need to get the atomic mass. Yes, 0 plus 1 equals 1. So it does work out. Let's have a look at oxygen. So I took that for my periodic table. Now, some periodic table will have a non-integer atomic mass. What do I mean? 8 is the atomic number, and I've got 15.999 whatever for atomic mass. What do we do then? How do I work with a non-integer number? There's a reason why it's not an integer, but at this point, what you got to do is just round it up or round it down, depends. Okay? So just like in math, so 15.9 is basically 16. Okay? All right, let's do it again. Do the same thing. How many protons there are? Okay, there's 8 protons. That's the atomic number. How many electrons? Not a problem. Also 8. How many neutrons? Not a problem. I'm just going to do the atomic mass minus the atomic number. I've got 8 neutrons. Okay? Same number of proton, neutron, and electrons. Again, there's a reason why it's not integer in the periodic table, but this is not the time to get into that. Chlorine. I've got 17 and 35,4. Okay. How many protons? That's the atomic number. 17. How many electrons? Also 17. That's the atomic number. How many neutrons? Well, I've got to take atomic mass, which I'll round down in this case, 30.4. 35.4 is like 35. So it will be 35 minus 17. You can see it's 18. So actually it has 1 extra neutron. Okay, I hope that made sense, guys. Please do similar question. I'm going to put it under here, under this video. Just find out the atomic mass. Find out the number of protons, electrons, neutrons for each one of these elements, and click on the song, the element song. You're going to enjoy that. Take care, guys. Have a lovely weekend.